This video is going to be getting you ready for your preparation of an alloy lab, which you'll be performing tomorrow in class. You will find the lab document on OneNote or also on the Teams page where you can access it to get all of your procedures and your materials and your questions that you'll need to answer. To give you a little bit of a background, an alloy is going to be a solution of two or more metals or non-metals, can be involved as well, but you have a solution which is just another name for a homogeneous mixture. So this is going to be something that is going to be created through physical processes, not chemical processes. And you're going to see that typically for your metals, the alloys are made as a way to kind of enhance the properties that they already have. So trying to make them more durable, try to make them less malleable. These are some of the reasons why we use the alloys. We have a couple different types of alloys that we will use. The first one is a substitutional alloy, and that's where the original metal, that's the host metal, will be replaced by metal atoms of a similar size. So again, look for elements on the periodic table that are very close together to help you with that. The example that you can use for that is what we're going to be using in our lab coming up, which is brass. Brass is an alloy that is made up of copper and zinc, and you're going to create this brass alloy in our lab using a penny. Now, you also have a second type, which is called an interstitial alloy. These are going to be alloys that are created by having a much smaller atom fill in the gaps between the metal atoms, the host metal atoms that are the larger size. So an example for that is steel. Now, when we look at this, the steel is made up of iron and carbon. So you might have heard the term carbonized steel or something like that. That will give you an example of an interstitial alloy. Wanted to give you guys a couple of quick pictures to kind of help relate the structure of these two different types of alloys. So the first type here again is a substitutional alloy. You can hopefully see I have some red atoms and I have some blue atoms. So when we're looking at these, hopefully you can tell the red and the blue are of approximately the same size. So the easiest analogy that I can give you to kind of help you understand the concept here is if you had a box that was filled with, say, tennis balls. If you think of another type of ball that's similar in size, you could go with a racquetball, you could go with a baseball. But if I had that box filled with tennis balls, and I took a few of the tennis balls out and I replaced them with either the baseball or the racquetball, that would be an analogy that you could use for the substitutional alloy. The baseball, tennis ball, similar size, so they could easily replace one another in that sample. The second type of alloy that we have is called that interstitial alloy. So as you can see in the picture, I again have red atoms and blue atoms here. The blue atoms are much smaller in size than the red ones, and so the blue atoms can then fill in the gaps in between the red atoms in that crystal lattice structure. The easy analogy that I can give you for something like this is to think about if you took a bucket of rocks and then poured in sand. The sand would not sit on top of the layer of rocks and have nothing in between. All the individual grains of sand would fall down into the bucket in between the different larger rocks and fill it from the bottom of the bucket up towards the top. That would be your example of the interstitial alloy. Okay, so I'm going to take a moment here and walk you through your lab procedures. When you guys come into lab tomorrow, you're going to come to your lab stations and you should find the following pieces of equipment out there. So the first thing we'd have is our hot plate. Notice with the hot plate, it's got a little part over here on the side for the on-off switch. Make sure it's on so you can see the light. And then we have two knobs. The first knob that's over here on the right-hand side, that's going to be for your heat. That's one that we're going to use tomorrow. We also have a stirring mechanism here as well if we're trying to run some reactions where we need to dissolve a solid into the liquid. We would use this as a quick way to make those solutions. So we don't need to worry about the stirring mechanism tomorrow, just the heat. For our lab tomorrow, we need kind of a medium-high heat for it, so we're going to turn it between 4 and 5. The dial goes between 1 and 10. So you want to have it somewhere between 4 and 5. You're going to find 2 evaporating dishes. If you don't remember, this is an evaporating dish. We talked about it as far as some of our lab equipment a few weeks ago. It's going to have 2 evaporating dishes. One of them has a liquid inside of it. This is the dilute hydrochloric acid. And then we have a second with some zinc metal in it. You can see the appearance of the zinc, if I get that into the camera here. So we have a nice shiny silvery colored metal. We looked at some of those last week as well when we were looking at the different properties for metals and non-metals. So you should also have a penny, which we're going to use. And typically we want to use newer pennies because it'll make them look better in the end. And then finally, you'll have a pair of tongs that we'll use as well. So as we're going through the lab, the first thing that you want to do when you come into the lab is you want to take some of our sodium hydroxide solution, which will be in this little volumetric flask, and we're going to pour it into the zinc, and then we're going to take that zinc and sodium hydroxide solution. That's going to form a polyatomic ion zincate, which is going to, it has a formula ZnO2 with a 2- charge, and this is what's going to bind to our penny to create our alloy. So we're going to take this, set it onto the hot plate, and then let that solution heat up. And in the meantime, what we're going to do is we're going to take our penny and we're going to place it into the hydrochloric acid. So I'm going to do this here really quickly just so you guys can kind of get a sense of it. Let me set this down here and get it where you guys can see it. So I'm not going to put it all the way in. I want you guys to use the tongs to do this, but I just want to kind of show you what you're going to see. I'm going to place the penny in here for probably around 20-30 seconds, something like that. And we're doing that to basically clean off our penny. We want to have all the oxides get removed from the surface so that we have a nice, clean, shiny penny. So the hydrochloric acid does this. When we use hydrochloric acid to remove oxides from a metal, it's a process that we call pickling. So I'm going to rinse this off really quickly. And then hopefully you can see here when I hold it up. I don't know if you guys will be able to see it very well, but I should be able to have a difference in the appearance of the penny. You can see the side that I had in the hydrochloric acid closest to the tongs over here, or away from the tongs here on this far side. That is the portion that is going to be more cleaned off. And then you have the other portion that still looks more like the dirty reddish color. So you're going to do that, but put the whole entire penny into the solution, let it go ahead and clear off the surface, and then once you do that, you can pull the penny out using your tongs and just rinse it off. So you don't want to stick your fingers into the hydrochloric acid. That will cause some chemical burns. So that would not be pleasant. Okay. Now, I'm not going to waste any of the sodium hydroxide solution now, but you would have the zinc and the sodium hydroxide solution sitting on your hot plate. You can take a paper towel, dry off your penny, and then you can just place it into your zinc and sodium hydroxide solution. And at this point in time, it's just a waiting game. So it's going to be probably about 15 minutes or so where the penny is going to get plated with that zincate ion, and you're going to notice a change in appearance. When it turns into that silver color, like the zinc metal, that's when you know it's done. The more zinc, the more silvery it is, the better it will be in the long run, so be patient. So when you do that, and it turns that zinc color, you've got 2 options. You can either have your penny stay a silver color, in which case you would again use your tongs to remove the penny from the solution, wash it off with the cold tap water, and then take a paper towel and blot it dry. At that point, you could go ahead and set it into your notebook, and as long as you don't apply a lot of heat or rub on it a lot, it'll stay silver for probably about 6 months to a year. And then if you want it to turn into a gold penny, then same type of process, take the penny out, wash it off, dry it. It's got to be dry, make sure it is dry, And then from there, what you want to do is place the penny onto the surface of the hot plate. And takes probably, again, 15, 20, maybe 30 seconds. You'll start to notice the appearance of the penny changing. It's going to lose that silver color, and it's going to turn into the gold color. And when it's finally that gold color, again, remember, hot metals look the same as cold metals. I had this happen before. I told you guys in class. I had a girl that went and did this, tried to take the penny off with her thumb, and had Abe Lincoln branded on her thumb for about a month. So please make sure, same thing, when you're taking the penny off of the hot plate, use your tongs to pull them off and place them into the cold water. You can just have some of the water running in the sink the whole time, just not on high, but just turn it on kind of low. You'll hear it sizzle. Leave it in there for probably about 20 seconds, 10 seconds, and the penny will come down to room temperature where you'll be able to touch it. At that point in time, you should be good to go, and you can just stick it into your pocket, and that gold penny should stay that way for years to come. So that will be our lab for tomorrow. Once you get done, the last thing I just wanted to mention to you is, as far as the breakdown process, what we want you guys to do with this is to use your tongs to effectively remove the container from the hot plate. Our countertops are heat resistant, so to properly do this, we don't want to grab it from the top because it can spill very easily. So what you want to do is instead just open up the tongs really wide, come up underneath, and kind of use it as a cradle to simply lift it off and then place it down onto the tabletop. And then just let it cool off from there. Make sure you turn off your hot plate and unplug it, and then it will be ready for the next class to use after that. So that wraps it up, and you should be all set to go for tomorrow. So I will see you then.